So in the second half of the course, we've already discussed application and mobile device security. Now we're going to begin talking about security for the host. We're going to talk more generically about host-based security. So we're going to talk about things we can do with the host. So we'll talk roughly about the environment, about the host, and some things that we can do. And then we're also going to talk about security controls for host-based security. So let's get started. We're going to start by talking about operating systems. And it's important to understand, some of the basics about operating systems when we talk about security. And I'll talk about that in just a minute when we talk about OS hardening. But first, just to give you an idea of operating systems and how they work, one of the conceptual things I always like to talk about with operating systems is if we start with the hardware, which is at the core of a host or of a system. And again, we've already talked about server hardening. So now we're talking about the client workstation or the host hardening. Just want to make that clear. But with a typical operating system, you've got the hardware, and I think we've talked about this before. You've got the hardware. Around the hardware, you'll have the kernel, which is the operating system itself. So the kernel or the operating system is what interacts with our hardware. And then wrapping the kernel is the shell. We interact with the shell. The shell is wrapped around the kernel, and the kernel is what interacts with the hardware. So we don't really have direct control of our hardware. We're doing all that through the kernel or through the operating system. So in the the kernel is the operating system, but the operating system sort of breaches both sides of that line. You've got the operating system itself, which is the kernel, and then there are components in the operating system which also kind of spill over into the shell. So there are some user interface things that most operating systems have, which again spill over into that shell. The shell itself is a utility of the operating system if you're using the command line. So speaking of the command line, the first way we can interact with most of our computers is through a command shell or through the command line running in the shell. So in the Unix world, we even call that the shell. Of course, in the Windows world, we usually call that a DOS prompt, right, which is the throwback to the old DOS operating system. You have Windows that we interact with. So Microsoft Windows GUI is really the shell for interacting with Microsoft Windows. And then you have applications that also sit in the shell. Things like TCP and other utilities will sit in the shell. Of course, we talk about TCP a lot, but all that's in the domain of the shell. And then you also have these frameworks, which they discuss a little bit in our book. So Java and .NET are sort of these abstraction layers, and there are programs that are even a layer outside the shell. So within the shell, you've got things like Java and .NET, and then you've got applications that kind of sit around that, even that are encapsulating that shell itself, which are applications written in .NET and Java and either the other scripted languages like Python or Perl or something like that. So this is generally how operating systems work. When we talk about OS hardening, so most operating systems include components that might be needed. So the problem is if you're developing an operating system, there's no way for you to know exactly what components users are going to need in their operating system. So you kind of create a generic operating system that has all these tools and utilities and services all sort of baked into that operating system. Well, we don't want a lot of that stuff on our systems, especially things that we don't need. And we've talked about this term hardening before, and we already know that in order to harden a system, what we're doing is removing unneeded components. So it's going to reduce the attack surface of the operating system itself. So important step in hardening or in host-based security is to harden. So when we talk about host-based operating systems, we're talking about things like Windows 7, Windows 8, even Windows XP, or a Linux-based or Mac type OS that's being used on the client side, although Linux is probably not used as often as Windows and Mac. But all of those could be client-side operating systems. And just like we harden on the server side, we're also going to do hardening on the client side. So if we're using Windows, we would remove unneeded services and applications. Again, we've talked about this before. We're going to remove unnecessary network protocols. So if you're not using NetWare or IPX, you would remove that. Anything you don't need in general, you're going to strip from that system. And again, this is all to reduce that attack surface. So there's fewer things that attackers can take advantage of. In the Linux world, we're going to remove unused daemons. So in Windows, we call them services. In Linux, we're going to remove those daemons that we don't need. We're going to remove any GUI or servers and things like that. We remove the GUI, by the way, in Linux because we really don't need the GUI in most cases. But of course, if this is a client workstation, then we probably have to keep the GUI. So I put in parenthetically there servers because we would only remove the GUI if it's a server. side. But since we're talking about host space here, the assumption is this could be end users. So we might leave some of those components, but certainly we can strip out all those things that we don't need. Certainly no harm in removing the GUI if it's not something that's required. For host-based security, we can also use anti-malware to protect our hosts out in the field or out on the floor or whatever you call it. So networking presents a nearly unlimited attack vector. Everything is on the network now, so lots of ways people can take advantage of the network to attack our system. So in your book, they talk about how the average Windows PC that's connected to the internet will be infected with malware in less than 60 minutes. And I think that's actually probably a long time. I've seen systems connected directly to the internet without a firewall, just connected directly, a Windows system, and I've seen it take far less than 60 minutes. If you have something that has a known vulnerability that's easy for these automated systems to detect, it could be as soon as a couple seconds or a minute. So it certainly is important to make sure that we protect against malware because it won't take long to get malware. So there are tools and products that are designed to stop these threats, and we talk about these in this unit on the host side. So the first is an antivirus. Its first job is to identify, by the way, I put the wrong word there. Instead of identity, should be identify. Its first job of an antivirus is to identify when there is a virus. And a lot of us, if we're using a computer, we may not know that there's a virus on our computer. An antivirus, however, should detect that. There are two methods that antiviruses can use to detect those viruses. One is signature-based scanning, and the other one is heuristic scanning. So basically, signature-based scanning is when the antivirus is looking for the telltale sign of a virus or the signature of a virus. So it sort of leaves its fingerprint. It looks for files that have a certain signature or a certain pattern. And it knows from looking in a database that that pattern matches to a certain virus, and it's going to assume that that's a virus. So that's certainly one method. The other with heuristic scanning is when you're not so much looking at the fingerprint, but you're looking at what programs are doing. So you're looking at how it's accessing files and sort of patterns of how it's interacting with the system to identify viruses. And usually a combination of these two is probably the best detection for viruses, to combine these two methods. So signatures are really good for detecting threats and viruses that are known, that are well-known viruses, and heuristic scanning can catch things more dynamically. So things that we don't necessarily know about yet, but because of the pattern of what's happening, we can sort of detect that that's a virus because a normal program wouldn't be doing those sorts of things. So again, a combination of those two should help us identify most viruses. Once it identifies a virus, its next job is to neutralize or remove, neutralize, I should say, and remove, hopefully remove that virus so it can't do any further harm. So first we identify, and then we neutralize and remove. So some features that most antiviruses have, they automatically update that signature database. So for those signatures to be effective, as I said, they are known signatures against known viruses. So as new viruses are discovered, that database of signatures has to be updated, and automatic updates can keep that happening in the background. Automatic scanning, meaning that it's constantly scanning for these viruses in the background. They can scan media, so if somebody plugs in, that's probably the number one way viruses are spread, is either through email or through attaching some kind of device. So I teach a lot of classes, at Drexel and the community colleges and things like that. And usually if I have a USB stick, if I stick that into a computer in a lab or in the library or in a classroom, in a lot of in the community college, it's almost a foregone conclusion I'm going to get a virus on there. So when I take it home, I want my antivirus to scan that before it tries to, before a virus has a chance to do anything on that USB drive. So certainly a good thing to scan media that's connected. And that could also be CD-ROM drives and floppy disk drives if you still have one of those. We could do manual scanning. So if I know I want to scan for a virus for some reason, or I know there's a certain directory, or I suspect that there's a virus, I should be able to manually do that. Scan any inbound email. So if you're using an email client, it should scan. And a lot of us now use web-based email. If you use things like Google for email or Yahoo, a lot of them have virus scanning baked in. So it's going to try to scan every one of your emails for a virus, and it will block anything that it thinks is a virus. And they'll have some kind of resolution, so they'll be able to fix problems that are caused by viruses. So these are the basic features of an antivirus. The next is anti-spam. So we all know what spam is, and I'm not talking about the canned meat. We're obviously talking about unwanted emails. So one method of protecting against spam is blacklisting. So you can blacklist known domains or known senders of spam. So that's certainly one option. It's fairly effective, but you have to know about that source before you can blacklist it. You can look for content or keywords that's typical of spam. You can have trusted servers, so servers that are not spammers, that you're going to always accept email from, that you don't have to do any of these little tricks to try to catch spam. You can do delay-based filtering. Delay-based filtering is when when spammers try to send massive amounts of email, when they connect to an SMTP server, if they don't get an immediate response or an immediate banner from the SMTP server, they disconnect and move on to the next one. So if you delay that a little bit, a lot of times those spam-based systems will move on to the next server and you won't even get that spam. So that's what they basically mean by delay-based filtering. PTR and reverse, or pointer record and reverse DNS, is when we receive an email, we look at the sender, so we identify who the sender is, and we try to do reverse DNS to see if it's a legitimate sender and see if it matches the from address. See if that all checks out. And so that could be another method to try to detect spam. See if somebody's trying to spoof something. Callback verification, roughly the same thing. Again, we're checking to make sure. So if callback verification is somebody makes a connection to us to try to send mail, we can do a callback, or we can try to send a message to them and make sure that they're real, that they exist, and it's a legitimate server. We can use statistical content filtering, which basically means that users can flag things as spam, and we can use that feedback to do a little bit of machine learning to try to determine what could be spam based on what's happened in the past. We could do some basic rule-based filtering, where users can basically say if the subject line contains something like stocks or Viagra or something like that, all these common words that we see in spam, we can block those emails because we know we don't want that stuff. Egress filtering is really about preventing us from becoming spammers. So in many cases, viruses and malware that we talk about, one of the things that some malware likes to do is hijack your machine to use it to send spam. So a lot of one method we can use to prevent spam is egress filtering, where we can block that outbound SMTP traffic that's trying to be relayed from machines that are within our network. So hosts on our network can unwittingly become spammers. So we can prevent that from happening. And some hybrid filtering, which is a combination of various techniques. So these are all some techniques that you have available for blocking spam. It's unusual to see these implemented on the client side. However, these can all be implemented in email clients and email servers, SMTP servers, and things like that to prevent spam. Spyware, as you know, is something that we learned about all this stuff prior, but spyware is basically designed to spy on you, to see what you're doing, to detect your keystrokes and things like that. So it monitors memory and network. Anti-spyware will monitor network and memory to detect spyware. Pop-up blockers, most of you know. Pop-ups are basically these malicious pop-ups that pop up over your browser over and over and over again. Most modern browsers include a baked-in pop-up blocker, so they'll block those pop-ups automatically. However, if they don't, you can always download a pop-up blocker. A lot of antivirus software comes with pop-up blockers. Although it's not as common anymore, but it's certainly something that you might have. And certainly something that we want to prevent, those pop-ups. They can be rather annoying. And also malware sometimes is delivered through those pop-ups. Patch management. So moving on from anti-malware, patch management, it's very important that we make sure that our systems have the latest versions and patches and all that stuff. So your book talks about some of the vernacular for patching. The first thing they talk about is a hot fix, which addresses an immediate need. So something that has to be fixed immediately. So a zero-day attack, for example, or a zero-day vulnerability, which we talked about before. We talked about what a zero-day vulnerability is. When that happens, sometimes you need to get a fix out very quickly. That'll be a hot fix. So it's a very informal patch that's usually very focused on certain functionality. So you'll get a hot fix that says, here's a specific fix for a specific problem. But then you might get a patch. So patches are usually fixes for bugs, for issues. They're usually not as urgent as a hot fix. They might have certain enhancements. They're usually more formal, so they've been tested a little bit more formally because they usually contain a lot of changes, perhaps. They're generally much larger than a hot fix. So hot fix is relatively small, but a patch is going to contain a lot more fixes and enhancements and things like that. So they'll generally be a little bit bigger and they'll be vetted a little bit more. So a patch, you'll usually get some kind of formal notification for a patch. And then you might get a service pack, which is a collection of hot fixes and patches. And again, a lot of this sort of comes from the Microsoft vernacular, but I think a lot of vendors have sort of adopted the same vernacular of having hot fixes, patches, and service packs. So that large collection is basically a whole bunch of patches put together into one big service pack. And I'm sure most of you are familiar with that concept of service patches. So patches and updates are most common in operating systems, and they're very large and complex. So you'll usually have these service patches and updates and patches all exist usually in operating systems. Both Linux, Mac, and of course Windows. And a lot of these terms really come from Windows. So you can whitelist and blacklist applications. This is another technique for host-based security. So basically, blacklisting is when we list programs that we know we don't want to run on our computers. So maybe we have, so in other words, we're denying the execution of a known list of programs. In other words, we might know that there's a certain program that we just simply don't want on our network. Maybe we found this program running on certain workstations. We've identified some flaw in that software, or maybe we know it does something that we don't want on our network. So we can blacklist it and say no one's allowed to run this program. One of the problems is it can be difficult for managing dynamic threats. So it gives you a little bit of a false sense of security. So we blacklisted these applications, but what happens when this new application comes on the network and can cause these problems? So it doesn't protect against new threats. You have to go in and add that to your blacklist. So, but the good thing about blacklisting is it requires very little management, because you can set it up for anything that you know you shouldn't run on the network, and you don't have to go in and constantly update it unless you know of new threats. When you know of a new program that you want to blacklist, you can certainly go in and add it. But that leads us to whitelisting, which is sort of the opposite. With whitelisting, we're basically providing a list of programs that are allowed to be executed. So it's an allow list. So instead of a list of things we're going to deny, we have a list of things we're going to allow. Anything that's not on that list, we're not going to allow on the network. So one of the problems with this is it requires a lot of management, because every time you have a new application that people need to run on the network, they're going to have to track somebody down in IT security to allow that application and whitelist that application. So certainly a lot more management. And in some organizations, you have to do something like this, but if you don't have to, most people won't do whitelisting. It's very effective for dynamic threats, because if anything new comes along that could be a threat, you're not going to be able to run that program because it's not whitelisted. So it does protect against those dynamic threats. In the Microsoft Windows world, you can do machine level policies with software restrictive policies. So this is a machine level policy to blacklist applications. You can also blacklist applications with UAC. I'm sure you're familiar with the UAC in Windows. That's the thing they added in Windows 7 that constantly pops up. Actually, it might have been Vista they added it, where it constantly pops up and says, are you sure you want to do this? Or in order to do this, you have to go get an administrator and things like that. But there's a feature in there called App Locker, which allows you to blacklist applications at the user level. Again, you can do it at the machine level, or you can do it at the user level. So you can apply a blanket policy or group policy to the whole machine that says nobody can run the following programs, or you can make it so only certain users can't run certain programs using the UAC App Locker. The concept of a trusted operating system is basically an operating system that's designed for security. So instead of building an operating system and hardening it, you're basically getting an operating system that's almost already hardened. It's already been vetted as being a secure operating system. It's typically required for government and military, and they use this thing called common criteria for IT security. It's been adopted by most major countries. So if you're doing any work with military or DoD or anything like that, you probably have to use trusted operating systems. There are versions of both Linux and Windows that meet that criteria. So they have versions that, if you're running these certain versions of Linux and Windows, they are considered trusted operating systems. They have all of the features and requirements to have the best possible IT security, given the technology we have available to us. I know that the one version of Linux that is probably one of the most trusted versions of Linux is, I can't recall the name of it, but it was developed by the NSA. And they certified it for use within the U.S. government for top secret and things like that. So that distro of Linux is pretty secure, so it's a good one to use if you're really concerned about security. Firewalls, we're all familiar with firewalls, as being devices, and you can take whole courses on firewall management to cover how to configure those and how they work and all that stuff. But when we talk about firewalls and host-based security, we're talking about personal or host-based firewalls. So beginning with Windows XP, there was a firewall that was included with Windows. Actually, I think it was Windows XP Service Pack 2 is when they started including that firewall. And so, of course, Windows Vista, Windows 7, Windows 8, Windows 8.1, they all include a firewall that you can use, that you can enable. In the Linux world, and by the way, you can also use third-party host-based firewalls. So there's also ones you can get that are third-party, things like Zone Alarm and things like that. But they're not as common anymore because, again, it's baked into Windows now. So most people don't download those, but that used to be pretty common. Included with Linux from the beginning of time, right? So Windows started with XP with a firewall, but Linux, since its inception, has had baked-in firewall capability using things like IP tables and TCP wrappers, which came along a little bit later. But most firewalls, so most commercial firewalls, if you go out and buy a firewall other than a Cisco firewall, which arguably has its DNA in IP tables, but any Linux-based firewall, which is just about all the other firewalls other than Cisco, really use IP tables for their firewalling function. So Linux is really, it's got this firewall functionality really just baked into the product itself. So it's definitely has a good firewall. So as far as being a host-based firewall, it's an excellent firewall on the host itself. And TCP wrappers are also a decent firewall, but IP tables arguably is the best option. TCP wrappers are okay, but they're not terribly secure for things like Apache and things like that, but they certainly can add a layer of protection. So a host-based intrusion detection system is basically an intrusion detection system that runs on the host itself. Now, most good intrusion detection systems are a hybrid of both host-based functionality and network-based functionality. And there's a whole course you can take on intrusion detection systems. So this is just a very basic overview of host-based intrusion detection systems. And these are basically the components that you would have in a host-based intrusion detection system. You've got, so the gray items you see on my screen are the actual IDS and also the rectangles you see that say user interface and reporting. So usually you've got this collector or sensor, which is basically looking at critical files on the file system. It's looking at network traffic, so traffic leaving and entering our host, and it's looking at log files. And it's putting all of that stuff together. So it's taking a combination of all these different things. It's aggregating that and pushing that into the analysis engine. And the analysis engine in this case isn't much different than an antivirus. It's got a signature database just like an antivirus does, and it's using that signature database to analyze all these log files, critical files, network traffic, put it all together, and figure out if something bad is happening. And then they provide a user interface that you can use to look at these possible intrusions, look at these possible threats, and decide what you want to do. And there's usually a little reporting engine, some kind of alarm device so that it can alert us that something is happening. So again, these are the components of a host-based IDS. What I don't have in that diagram is heuristics. So most good IDSs are going to combine both signature and heuristics, just like we talked about in antivirus. The difference is that this is combining all these different things. And by the way, it's a very blurry line nowadays as to whether it's an antivirus or a host-based intrusion detection system when we talk about the host side. Now, on the network side, intrusion detection systems pretty much stand by themselves. There's really no blurry line to an antivirus. But on the host itself, antiviruses have a lot of this functionality. And likewise, an IDS arguably can also be an antivirus. So they're going to examine log files, traffic, audit trails. It can identify malicious activity by looking at activity in strange time. So something's happening at 2 o'clock in the morning when there shouldn't be. Authentication failures, new user accounts being created, access to critical files that normally wouldn't be accessed by certain processes and things like that. Modification or removal of binaries or executable files. Activity when there shouldn't be activity. Privilege escalation, which is when a file is or when a user is escalated to root or to administrator or something like that. So lots of different things that our IDS can look for in order to identify that there's a threat. So some advantages of a host-based intrusion detection system. It's specific for the host environment. So it's usually very focused on what that host does. So for example, a host-based IDS that's running on a web server can understand that that's a web server and know specifically what it can look for, especially if maybe it's on Apache or IIS. It would know exactly what types of patterns that would be appropriate. It can reduce false positives because of the focus on that specific platform. The data on the host may be examined unencrypted. So one of the problems with data as it's moving across the network, if we have good network security on our network, we encrypt that traffic while it's traversing the network, but that means that a network-based IDS would have difficulty analyzing that traffic, whereas a host-based IDS can see that information because it's not encrypted when it's on the host in some cases, although we'll talk about that later on when we talk about controls later on in this unit. It can be application specific. As I said, if you're running a web server, it might know that it's working with Apache, or if it's working with IIS, it'll know exactly which log files it can look at to identify any patterns of malicious activity. There are also some disadvantages. One is that it's not very scalable to have host-based IDS on every single host, because it has to exist on every system. You have to install it in every system. So there's a higher total cost of ownership, or TCO, because we have to have it on every system. It uses system resources. So just like an antivirus, and that's one of the big complaints I always hear from people about antiviruses, is that they use a lot of resources on the computer. And a lot of people will shut off their antivirus because they feel that it's slowing down their computer. And IDS is arguably even more intensive than something like an antivirus. So it could use a lot of resources. So that's certainly a concern. It does not relate to activities that are outside the host. So a good network-based IDS has much better heuristics because it can look at everything happening on the network. But a host-based IDS doesn't know what's happening on the network, so it only can look at itself. Although, like I said, a good IDS is a hybrid of host and network-based IDS. It can be compromised or disabled. So if somebody owns the computer, if somebody hacks into the computer and has root access, they can just simply disable the IDS if they know that it's there and they know that it's operating. So some advancements in IDS, a lot of them have integrated firewalls. It has heuristics as well, signature-based, so behavioral is very similar to the concept of heuristics that we talked about earlier. Application control, enterprise management. In other words, if you're deploying a host-based IDS across an entire enterprise, there are some management tools to do that, to make it a little bit more scalable and to mitigate that disadvantage we talked about. They have malware detection, as I talked about before. That's kind of a blurry line now. Host-based IDS can do a lot of this antivirus and sort of malware detection stuff that we talked about. So it mitigates the need to also have an antivirus and to also have anti-spyware and pop-up blockers and all that stuff. It might be kind of baked into that host-based IDS. So as far as hardware security, when we talk about hardware, we're talking about servers, workstations, devices, and we can secure that stuff with things like cable locks. We can secure our data in safes if it's removable storage. We can use locking cabinets. So all kinds of things we can do to secure the hardware itself. And we talked about that in much more detail in IT Security 1, so I don't want to get into too much detail in this course. But just understand cable lock, safes, locking cabinets, those are important keywords to remember. So baselining, just like an operating system should be baseline, we can also use these same techniques when we're talking about specific applications and software. So we could do application layer baselining in addition to the operating system baselining. So we can create a uniform baseline for any widely implemented software. So if we have software that's implemented enterprise-wide, the same application, and it's implemented over and over and over again, we can establish some guidelines and procedures to deploy that application in the most secure way. So if we know that there are certain settings or certain patch levels that we need. Good example for this is Microsoft SQL Server. There used to be a worm called a SQL Slammer worm that affected almost every Microsoft SQL Server, and they had a patch for that. So one important step for baselining Microsoft SQL Server would be to make sure that that patch level was always installed, because you knew if you didn't have that patch, it was only a matter of time, sometimes just minutes, before you would get that SQL Slammer worm. So that's a good example of baselining for the application layer. And finally, in this part of the unit, and there's another lecture video after this one, so there'll be a part 2 lecture video where we talk about some additional topics. But virtualization, virtualization is all the rage now. We've talked about virtualization before, and I'm sure you've talked about it in many other courses. So virtualization is basically when you have many different systems all running virtually within one system. And I don't want to get into too much detail here because I think most of you probably are familiar with it. And you can certainly do some research to find out more about virtualization. But basically, the subsystem that handles this virtualization is called a hypervisor. So that's basically what manages these virtual machines that might be running within a host or on a machine itself. So Microsoft Hyper-V is one option, VMware is another, Citrix Zen is another option, Parallels. Your book talks about all of these. Your book mentions Oracle VirtualBox, which is no longer being developed. I think it's been shut down. Oracle Virtual is a great product, but it's no longer available. But that was a host-based virtualization platform. I think you can still download it. And it is still a pretty good product, but it's not going to be supported on newer operating systems. Your book talks about this idea of snapshots, which is when you have a virtual machine, you can take a snapshot of a machine, thus backing it up. So if you do have virtual machines, you can take snapshots of them before you're making any major changes. That way you can roll back using the snapshot. One thing that I would caution you, however, is that with almost all of these virtualization platforms, snapshots are not a good method of doing your backups on a regular basis. You still want to use more traditional backup methods to do that. Snapshots are not very efficient for backups because you're backing up a lot of operating system files. So if you have 20 virtual machines all running Windows XP, for example, and you snapshot all of them as your backup plan, you're backing up the same operating system 20 times. It's a lot of space. It's not very efficient. And also, most of the virtualization platforms really don't recommend doing that. But snapshots are a good tool for either rapidly deploying or for saving the state of a machine before you make any major changes. Elasticity is basically this idea that if you have a server that has a finite amount of resources, certain machines can use more of those resources at different times. So we don't have very good elasticity when we have 5 servers each running their own operating system, because if 4 servers only need 1 gig of RAM, but one of them needs 8 gigs of RAM, all of them really have to have 8 gigs of RAM in case they need it. But if we have virtualization, we can have all 5 servers on one, have a total of, say, 16 gigs of RAM, and at any given time, one of them could be using 8 and the other 4 could be using 2, and we're still under that 16 gigs of RAM. So it's more dynamic. You get that elasticity there. So that's what they're talking about with the elasticity. And sandboxing is being able to test things. So with sandboxing, you can isolate a virtual machine, put it in its own little sandbox, so you can try different things. You can try patches and updates in an isolated environment. You can try new software. You can test how it's going to perform. You can test how it's going to react to certain types of attacks. So all kinds of cool things you could do with sandboxing. So that's also an important concept. And it's definitely a good thing to have in our toolbox for IT security. It gives us a lot of flexibility when we're testing things. And again, we can keep it isolated in that virtual environment without causing any possible harm to other systems. So that's basically virtualization. So in the next video, I'm going to continue this discussion a little bit. We're going to talk about host-based security controls. So we're going to talk about some mitigating things that we can do so we'll talk about things like encryption and so forth and so on. So we'll talk about that in the next video.